Howdy. So you can probably tell this video is different than my previous ones that I have put on my channel. And that's for good reason. I'm really tired of consuming content every day on YouTube. I have like 3 or 4 hours of just watching YouTube shorts like every day on my phone. And that just, I am disappointed in myself because of that. So I've decided I'm going to start making some stuff. Maybe that's making content. Maybe that's just making things in my life. So I'm hopefully going to be able to share some of my projects with you and get some feedback, get some ideas going. You guys have ideas for stuff I should make, please let me know. But without further ado, I'll give you guys a rundown of what I'm working on. All right, so kind of the rundown of what this machine is going to do is it's going to take what's called a protoboard, which is a super thin layer of copper on top of a piece of fiberglass kind of insulation material, and it's going to turn this into a circuit board kind of thing. So proto boards are different types of it. This is considered a single layer board right here, where it's one layer of copper and then a layer of insulation. A dual layer board looks more like this, and then a 4-layer board kind of gets more into the, just kind of keeps stacking layers like a sandwich. So I'm going to work with single layer boards just because it's a lot easier. I only have to worry about one layer of copper to do, and I only have to insulate one layer of copper. So there are 4 different methods I can use to cut out the traces on this board, which are masked photolithography, maskless photolithography, using a CNC bit, and a fiber laser. So the masked photolithography is where I take like a stencil and I just cover up different areas of the copper, and then with a chemical bath system and curing under UV light, I believe. I'm not entirely sure on this part. Shine out UV light all over. Where the stencil isn't, it removes the copper kind of thing. So you can cut out systems like this, and then you run a chemical bath that destroys the stencil kind of thing. Not entirely sure. I don't want to do this method because of the chemical processes I have to deal with and the time consumption on that. It really kind of defeats the purpose of trying to get a board done really fast. There's maskless photolithography, which means I don't have to worry about the mask at all. I put this under a chemical bath, and then I direct the light using like a projector of some sort. This method was shown to me by a member of the Cyberdeck Cafe Discord server. A big shout out to them. But you shine kind of UV light in a specific pattern through like a microscope from a projector screen kind of thing. Weird method. But then again, if the chemical reaction with the UV light removes where the UV light hits kind of thing. A couple of different pros of this. Again, no stencil. Cons kind of going into it is that it still is a lot like, I got to deal with a whole bunch of different things with this. I'm not entirely sure I can do holes with this, which means I have to CNC out the holes for the board as well. Trace wise, this is pretty good. Gets into kind of some issues though, depending on if I want to get into multicolored boards where I have like a green background, and then I'll use like right here for words if I have like text or something on there that I need for different things. So getting into it, the third method here is I can use a CNC machine where I could have a drill bit of some sort come in and then clear out the material. A couple problems I'm kind of seeing with this is that if I have a really thin bit for if I want really close traces, it could break off in the middle here and cause some issues because it's a really thin piece of steel. They might not even make bits the size I need, which would be really kind of a pain in the ass. But it would be kind of nice to be able to just kind of remove material where I need to. I can drill holes this way real easily. No real big issues with that. The fourth method I'm thinking of, which is what I'm actually leaning towards, is using a fiber laser. A fiber laser would allow me to just kind of shine light in specific areas, the board, kind of like the maskless photolithography. And where that light hits, I can remove the material, the copper, and then if in some areas I might even be able to remove the remove the insulation as well, so I can make through holes for screws, or I need parts that need to go all the way through kind of thing. Very much that's kind of what I'm leaning towards working with. I think it's going to be pretty good. So that's kind of the process there of getting the traces made on a board. Then let's say I have traces here, here, and here. You can run a board just like this and just solder on the components you need. This is a very basic board, very good for quick prototyping. But if you want like a solder mask on it, which is what makes the PCB boards green. You have to do that somehow as well. So the way Stephen Hawes in his video on this, I don't know if I've said this already. It's really late at night for me. He used like kind of a silk screening method to cover his boards, where he'd put on a thin layer of green kind of over the copper there, and then he used the fiber laser method, where he would then remove the green in specific areas for when he needed to access traces, or when he needed to kind of get some of that. Then I kind of want to take it another step forward from here as well, possibly depending on how it's going. Is that I'd like to add text in. I want to add gray in some areas, so I could have kind of legible areas. So I could say, hey, this is my 555 chip. This is my I need this resistor in this spot kind of thing. That kind of size. It kind of gives you an idea of, oh, this is where the components need to get put onto the board. So it's not just green with some traces on it. But that's kind of the idea of what the process is going to be. I will kind of show you on what I've designed so far. All right, so this is the PCB dispenser prototype I'm working on. Currently, the green board here is the prototype board or proto board size and shape that I'm working with. And I've designed this system kind of to run off of parts for like a Cricut cutting machine. These black rollers here are actually I can buy on Amazon they're made for a Cricut roller. It's a 9mm steel bar in there I'd cut to length. Set of bearings that I can find on Amazon as well. The interesting thing about this stepper motor here is I actually own two of them. I got them at Micro Center a while ago, and I haven't really had a chance to use them. So I'm hoping to use them with this project. But the idea here goes is that when the stepper motor turns, it should dispense a board. I don't know why it's not working. I think this is the one I have to move. So the idea goes is that it'll dispense a board out, which will then fall onto some sort of rack down here, and kind of get the idea. You should just kind of dispense out there. I haven't tested any of these parts together yet because I haven't been able to print anything, like I said earlier. So that's the dispensing idea, kind of just one more kind of go around. Then I have kind of what I consider the, let's see here, kind of the actual tooling arm, I guess is kind of the right way to put it. Same stepper motor and kind of a rack and pinions system is what I'm thinking of here. And then you can just kind of move the tooling arm where yep, this works better. So the idea goes is that you extend out the tooling arm completely. So then the board will be dispensed kind of out into this area. And then you bring in the tooling arm, so then it's nice and close, so that you have plenty of clearance area. The interesting thing about this, again, I'm still very new to the CAD system, is that as I move this, you can see how the teeth here kind of mesh weirdly on the rack and pinion system. I don't know why it does this. It really shouldn't. I thought I designed the teeth right. I really think I did. I think it's just a fusion thing. But I haven't been able to test this since I haven't been able to get a good print yet. So that's some of that system. I'm not completely done designing this part of it, which is the actual arm movement system vertically. There's a couple of different ideas I had for the arm. I could have done like an actual like robotic arm. I could have done a couple of different axes kind of system. Could have done a full gantry, so this entire machine could just run on a like kind of a straight line, more or less. But what I'm thinking about is having it so that the machine, you have like down here you have your storage, over here you have your laser, over here you have your output, then in between you have your soldering station and your curing station kind of thing. Just kind of so it just rotates around perfectly. So right now I kind of have it so you could bolt on that tooling right there. You have a stepper motor right down here. It's a NEMA 17, I believe. It's been a little bit since I've looked at these files, but believe a NEMA 17 motor, it'll just spin a piece of 2020 extrusion around that the tooling will run along. I got to find a way to move it vertically with this secondary motor here. I'm still coming up with this idea. Any suggestions is definitely appreciated, but so far that's kind of what I'm working with. And then over here on this part, this is kind of my storage rack system that I came up with. Um, so again, the green board is the proto board size. I've used that on as many designs as I possibly can. So then so I can keep sizing consistent because I am been known to forget measurements. But this idea here is that I could store a whole stack of just parts. Just stack them all up. They fall down, and then you can drag them out from right down here. There's a little bit of clearance so you don't accidentally rub the copper. Um, this front left or right corner up here is a little bit higher, so then when you line up the boards, you can just shove them right into that corner and they'll slide right down, kind of thing. So that's just kind of an overview of the parts that I've been designing. All right, so you might be wondering, why design this? Why build a machine like this with all these different components and all this complexity? Wouldn't it just be easier just to order a board from a board shop or get someone else to make it? Well, I want to learn how to be better with CAD software and designing boards. And I've actually had a lot of fun just coming up with ideas and different ways to figure this out and decide what works, what doesn't work, what could I make better. That's always been kind of fun. And really think that'd be kind of a fun thing to do. I'm hoping to eventually, if I can get this machine working, to send out the files and the code for everyone to design a system like this if they have the money or the opportunity to. And I hope to eventually make a version that can hopefully do two-sided boards or do larger boards in general. Right now, I just kind of want to figure this stuff out and see if it's possible. I think it is. I just have to figure out how to do it. Also, earlier in the video, I was talking about how I don't have a working printer, and I didn't really talk about it earlier before that point in the video. I've been kind of recording these sections as they come along in my head. Just for a little context, this is the machine. This sensor right here, this thing comes down, levels off the bed from there. That sensor, from what I can tell, has an accuracy of 0.04 millimeters. The stepper motors move at a height of 0.05 millimeters, so it's very inaccurate. I have a BL Touch coming, and that should hopefully like cover it, because the BL Touch has an accuracy like 8 times better than this sucker. So hopefully that will solve a lot of my problems, and I can actually start using this machine. I've had some bed adhesion problems, so I have a dryer over there that's running. Hopefully it'll keep this stuff nice and dry and it'll work. But other than that, that's the end of what I'm working on right now. Hopefully I'll have another video coming up in a couple of days, just kind of going over maybe time-lapse footage of this thing running. So I'm hoping that works. Anyway, thanks again so much for watching and sticking all the way through if you did. Again, huge shout out to Stephen Hawes' video for giving me the idea for this, and a huge shout out to the Cyberdeck Cafe community on Discord for kind of just having space for me to upload project information when I'm working on it, and being a great source for just all things Maker. So anyway, that's it for the end of this. For now, thanks again so much for watching.